So, how has your life changed since it broke?
I have to go through life scared, knowing that I'm not protected anymore. I'm frightened. I'm vulnerable all the time now. I used to walk around and not have to worry about anything. I was the strong one. I couldn't lose. It was awesome. But once it was gone, I started losing. I was weak, helpless.
Could you tell us how your cell wall used to work for you?
It was made of cellulose, rigid, strong. It was all around me. It protected me. It made me feel safe. And now I just don't have that anymore. It broke 1 year ago. It was just a normal day, carrying around a load, My cellulose broke. I guess it couldn't handle that stress. I couldn't live with my cell.
That's tragic. So, when did you change your shirt when we went to that flashback?
Let's calm down here, Paul, alright? We're talking about my tragic life right now.
Alright, why exactly did you need that cell wall?
It just keeps my innards in place. My cytoplasm will leak out if I don't have it. It helps control substances coming in and out of me, being the sensitive cell that I am, and single cell that I am, ladies. It was really important to me. It's really important.
Good evening and welcome to the 6 o'clock news. I'm Philip Browntrout. You may be wondering why you've just seen a story about a very sad little cell whose cell wall broke. The fact of the matter is, cell walls are incredibly important to the world. Without them, plants would collapse, and with collapsing plants, there would be no plants. Without plants, there's no producers for our ecosystem. And therefore, without cell walls, the world would come to an end.
Alright, so Doctor, could you just give us a quick introduction and some information on cell walls, please?
Oh, right. Hello, my name is Dr. Science Van Pumpernickel. I'm an expert on cell walls. You see, there are two components of a cell wall. There's the primary wall, which is composed of pectin and polysaccharides, and they form a matrix, you see. And inside of that matrix, there are thin strands of cellulose, which give the rigidness to the cell wall. But still, the cell wall remains thin and pliable, allowing for expansion. If that wall is too thin, however, then a secondary wall is required. That secondary wall is simply on the inside of the primary wall and just gives structure and shape to the cell wall.
Alright, so thank you, Dr. Van Pumpernickel, if I got that correct. Was that correct?
Yes, sir.
Alright. I will see you on another time. Hopefully not, though, so goodbye.
Excuse me.
Goodbye. Hello. Obviously, you can tell my interview with Van Pumpernickel went quite swimmingly because of our similar hairstyles. Next, we have an exclusive interview with the leading scientist in the world on cell wall junctions. So, Doctor, just give us a quick introduction and then I'll get you your question.
I'm Dr. Bolt. If you wonder about my ear, I lost in a lab experiment. It's fine, though. I can still thunderbolt people just fine.
Oh, that's just grand. So tell us a little bit about cell wall junctions.
So let's start with a question myself. What exactly is a junction? It is a molecular structure where information is exchanged, or where cells glue themselves to cells of a similar kind. There are three types of these junctions. The first is a tight junction. This kind connects the cells to body tissues, including organs and epithelia. The bond the junction makes doesn't allow for water-soluble substances to pass through, explaining why gastric juices don't get out of the stomach. Another kind is an adhering junction. This type is placed in places where there is constant stretching, such as the heart and skin. The last type is a gap junction. This one is quite neat indeed. In this junction, cytoplasm is adjoined with other cell cytoplasm, allowing for speedy transport of material.
All right. Thank you very much, Doctor. And now we'll have to take a look at those pictures and let you explain them a bit further.
Alright, so first up we got our gap junctions, which have conjoining cytoplasm, which allows for speedy transport. After that we got our adhering junctions, which are for constant stretching. And last up, we got our tight junctions, which are used to keep things out of where they're not supposed to be. So if that's all you need me for, I'm going to go have dinner with my wife and my peach juice.
If you haven't already noticed by our utter lack of hints in our report, this report is actually about a campaign. A campaign for the most important cell organelle of all time. In a great quote by the great Robert Hooke, "Cell walls exist. This obviously shows that the cell wall is superior to all the other organelles. And if you don't think that, then you haven't been listening to our report." I'm Robert Crankshaft here. I'm Robert Crankshaft here signing out, saying, please vote for our cell wall if you love America.
You guys are in and out of your house just so much, so casually.
He just left.
I know.
Oh, jeez. I think I'm good. Oh, shit. Are you fucking kidding me?
Oh, jeez.
You crack it?
It's so delicate. Holy hell. Jesus, I barely dropped it.
You crack it?
Yeah. Ah, shithole. God damn it. It's recording.